Okay, we're asked in this uh, example to draw a free body diagram for the situation shown here where a hand is pushing a less massive block which is in contact with a more massive block, and the AB system is accelerating to the right, and there is no friction on the surface. And then we're asked to rank all the forces, and we're asked to focus on horizontal forces. So starting with block A, which is in the middle here. Block A is going to experience two horizontal forces. It's going to experience the force of the hand on A. That's a contact force pushing it to the right. But since it's in contact with block B, there is a backward to the leftward force of B on A. Now, since there's the force of H on A, that means that there's a reaction force of A on H, and that's the only force that's acting on the hand. The only horizontal force that's acting on the hand. So that's a Newton's third law pair. And then we can also say, because there is a force of B on A, there must be a force of A on B. And in fact, that's the only contact force, the only horizontal force, in fact, that B experiences. And so that's a second Newton law pair. So since the system is accelerating to the right, since A and B, which is the system, is accelerating to the right, F of H on A has to be bigger than F of B on A. And the single force acting on B, F of A on B, is equal to F of B on A. So therefore we can say that F of A on H is equal to F of H on A because of Newton's third law. But because of the middle picture, this one right here, F of H on A has to be bigger than F of B on A. But again, because of Newton's third law, F of B on A is equal to F of A on B. So there's the ranking. It's a result of Newton number 2 combined with Newton number 3. And you should be able to look at this sketch on the bottom here and understand why the F net acting on B is larger than the F net acting on A.